Hey everyone, welcome back. Now before we get into the next section, I wanted to review what we've learned so far. And for that, I put together these 5 bullet points. So first of all, we learned how to group data and that it's useful. The group by statement is this powerful thing that allows us to apply our aggregate functions in a smart way against groups of data rather than summing up the entirety of the data. So it's super useful. Now, we also learned that grouping happens after the from and the where clause. And we learned that the having clause is a special filter for groups that acts like the where clause, but it's for the groups. Cool. Then we looked at grouping sets. And what are grouping sets? What are roll-ups and what's useful about them? And how can we apply them to multiple groupings in a single query? Grouping sets are a super useful tool. Then we saw that grouping data is not a silver bullet. And how we saw that was we were trying to get the current salary of an employee. But we hit some walls there. And we could either get the latest date that their salary was adjusted or their highest or lowest salary. So grouping data, although it gives us this ability to get certain outputs, it isn't a silver bullet. We can't answer all questions with it. So what are we missing? Well, the question becomes, how do we apply functions against a set of rows, a group, related to the current row? Now, what does this mean? Well, how do we take the calculation that we can do against a group and show it against a current row? Now, what do I mean by this? Well, let's take a simple example. What if you wanted to know the average salary for a department? And I can hear you saying, Mo, that's easy. We've already seen that. We know how to do that. That's the simplest query in the world. And you'd be right. We have seen this and we know how to do this. We would do something like select department name and we would do the round of the average salary and we would select from salaries. We would do some joins and then we'd group by department and bim bam boom, we got ourselves an average salary per department. Well, that was easy. And now let's say, what if we want to add the average to every salary so we can visually see how much an employee is from the average? Now, think about that. Well, we've calculated our average and we know the average per department. But let's say we wanted to do a query. And in that query, we wanted to see, hey, well, this is my salary and this is the average for my department. And I could see it right beside my salary so I can see how far off I am from that average. Well, what do we do now? That's not so easy peasy. What do we do? How do we do this? Welcome to window functions. Window functions. This is what we're going to look at next. And this is going to be able to answer that specific question. So let's jump right into that. I hear you asking yourself, what now? What is this window function? And what exactly are we trying to accomplish again? Well, the problem statement was, what if I want to show something beside my row based on a group calculation? So we learned group by, and we learned that with group by, we can do calculations against groups. Now, the following is, hey, what if I want to show that calculation against a group beside my row? Now, that's an oversimplification of what window functions actually do. So let's look at the actual definition. Window functions create a new column based on functions that are performed on a subset or window of data. Okay, let's break that down. So we're applying a function against a subset or window of the data. What data? Well, the data that we're requesting in our query. A window function can only be applied against the window of data that we've requested. So the window of data that we've requested is the window of data upon which we can apply a window function to perform a calculation to give us back an answer. Now, this becomes extremely important when you want to do data analysis against some of the data that is returned. Window functions have many, many applications. Do you see them as often out in the wild as possible? Well, if your job is doing a lot of data analysis or trying to crunch some numbers, do predictive analysis, you may find yourself using window functions a lot in your day-to-day querying. Now that said, what does a window function look like? Well, here we see the syntax, and we've been through this 100 times so far. How do we apply this in real life? Well, we have something called a window function, and it can potentially take arguments. So it's a function that takes arguments. Now, the key part here, and I cannot stress this enough, is that for a window function to be applied as a window function, you need this over keyword, because it's going to tell you, hey, apply this function over this window of data, this subset of data. And optionally, you can give it a partition, you can give it an order. We'll get into what those specifically mean. They're optional parameters. If you just pass over, it will apply against the entire window of data that you requested. Now heed my warning. If you request 10 million records, the window function applies against each individual row. So each time that you apply a window function, it's going to apply again and again and again against that entire subset of data. So you request 10 million records, you're going to apply the window function against those 10 million records 10 million times. So your query is going to take a long, long time. And so window functions by nature can take longer to run because they run against the entire window of data for each individual row. That's very important to remember. Now, what if I asked you, hey, let's apply this window function to get the maximum salary and show it beside each individual salary? Well, let's look at how that would happen. Over here, we're in Valentina Studio. And if we look over here, we have this very basic query. Very, very basic. We are selecting the max salary from salaries. So let's execute that. And what we can see is our highest salary is $158,220. Now, if I asked you the question, well, how do I show that max salary beside each individual row? So I want to be able to base, hey, this is my salary, and base it off of the max and kind of see, hey, how far am I from that max? Well, we just learned how. So knowing that, we can apply a window function, right? And so we said, all right, we did max salary, right? Cool. So if we do this, will it work? Well, of course not. We specifically said, hey, we need this over keyword in order to make it apply. Well, that should do it, right? Nope. Again, over is a function, so we need to add the parentheses. And what this will do is it will tell it, hey, just go over the entire data set. Doesn't matter. Just get me the maximum value across all of the salaries. But it's going to do it for each individual row. So what you're going to see happen here is this query is going to take a little longer to execute. And so let's start counting. 1, 2, 3. I'm just joking. I'm not going to count and count, but you can see the query is taking a longer time. But as it goes, what we can see here is that for each individual row, we are now getting, hey, this is my salary, and this is the highest salary that's paid out in the company. And you can kind of start comparing and contrasting as you go along. Very, very useful. We know now that we can apply a window function against a column. So there's a function, a specific function, in this case max, that we apply against a column. And we're saying, hey, apply it against the entire window of data. Now, in order to compare and contrast here, let's say that we were only applying it against the top 100 and we did a limit of 100. Just do it against 100 records. Well, what you're going to see happen is it's going to execute faster and faster because, hey, we're only selecting the max from the data set that is required. But wait. If I'm only selecting the first 100, how am I getting the maximum salary? Well, the window function applies against the window of data. So anything and everything that comes back from salaries. It's no coincidence that in this top 100, we do not see 158,000 anywhere to be found. So it applies against the window of data before limits and filters are applied. If we said where salary lower than, and let's say 70,000, well, let's see what happens then. So we can now see that it applies against the filters. So now we're getting the highest one in the filtered range. So the window of data applies against filters, but it doesn't apply against limits. So if we say, hey, limit my data set, cut it off at 100, I don't want to see that. I don't want to see anything beyond 100 records. It's still going to apply against the entire data set. But when we apply filters, however, when we say filter my data set, it's applying against that window of data. So it's very important to understand how queries execute in this case, because the window of data is directly related to whatever the query will return. Now we've literally filtered out any salaries above 70,000. So therefore, our max salary stands to reason. Someone is being paid 69,999, so that's going to be our highest. But when we use limit though, what limit is doing is just saying, hey, of everything requested, just show me 100. It's not a true filter. So it's important to understand that, right? And it's important to know what the window of data refers to. The window of data refers to data that the query calculated out, not what limit cuts off. It's literally what the query returns itself. When we use limit, the query is still returning everything. We're just saying, hey, cut it off at this number. But when we apply filters, we're saying, hey, of all of the data that you got, just show me this. So the window of data narrows. Okay, so with all of that being said, let's look at the other things that we can do with window functions. We just saw the possibilities of a window function and how simple it is to apply against each and every row. Now, when looking at it, we used the max and we used a very simple syntax. We just used over the entire window. And then we saw that the reference of the window of data changes as you apply filters. The where clause can change the way that the over function applies. But we also saw that our queries can take longer to execute because as that window of data grows, as we return more rows to the window function, it takes longer and longer to apply depending on the function that we're trying to apply against each and every individual row. We didn't really look at partition by or order by. And so I quickly wanted to run you through them. Partition by is used to divide rows into groups to apply the function against, and it's optional. Down here we can see a window function as normal without a partition, where we take the average salary over the entire window and we say average global salary. But we could extend that and we could do average department salary. So let's look at what that would look like. So over here we have our previous window function. So let's switch that to average salary and let's do it over the entire window. And then what we're going to do is we're going to calculate the average salary against the entire window. And what we can see is that we are getting the average salary with a rounding against each and every row. So this is the average global salary, 63,810. Now, what if we wanted to do that by department? Well, we would need to know in what department each employee sits. So let's join the department employee using the employee number. And so what that gives us is the department number of each employee. So let's do this as DE. And what we can do is we can also join departments so that we have the specific department that they are in. And let's do that as D. And let's do using department number. And so what this gives us is a very simple join syntax that allows us to say, hey, with every employee, give me the department name. And then let's see what happens here. So we're still going to get the average global salary, but we're going to see in which department each and every employee works. And so what will happen here is we're going to change the average global salary to be the average salary by department. And we can see that a lot of these people work in human resources. So let's say, well, what if we wanted to partition it by something simple? So let's do partition by d.department name. And by doing this, we're now going to group together the data by the department name, so everyone in human resources, and we're going to calculate the average salary against each and every department by the name. So when the data returns, what we'll end up seeing is that we'll see the same result for all of human resources, and then we'll see a different result for quality assurance and a different result for sales and so forward and so forth. And so what we'll see here is, okay, customer service has an average salary of $58,770. And then if we go down, well, we can see that, for instance, a different department like development has an average salary of $59,000. And if we go down even further, we can see that human resources has $55,574, and so forward and so forth. So you can see how partitioning the data can help you draw more insights. So now I know, well, for this employee, based on the department that they're in, I will know the average salary for their department. And because I'm partitioning by department name, it's going to return it as a column. So I can remove this one here. I don't really need to show it. And by partitioning it in this way, we can now draw the conclusion of, hey, in this department, you are this off of the average salary. This gives a lot of insight into the way that the business is operating. Is salary compensation fair? Well, you can see that they're making $42,000 and the average is $58,000. So we can see that our window function has generated the average salary per department. And by partitioning, we have returned both the column that it was partitioned by and the average salary. And we can rename the average salary to say average department salary or whatnot. But partitioning is huge. Partitioning changes the lens of the window function to look at a partition, a subset of data. In this case, a subset of data by department name. So partitioning in window functions is huge to draw deeper conclusions, to draw grouped conclusions, grouping by department name, for instance. And knowing this, we now know that we can run more in-depth analysis. If you're doing analysis, window functions are huge. They're so beneficial. So let's take a look at what order by does. So now let's take a look at order by. Order by, typically, we've used on a query level, select from where order by, but order by can also be used in a window function. And it is used to order the results. Makes sense, it's called order by. But within a window function, order by operates kind of strangely. Now, we've seen partition by, and we've seen how partition by kind of takes our results and puts them into groups and groups them together into what we call partitions. But order by operates a bit differently. Now let's take a look at that, because a visual example will explain it better than any example I can put into slides. So here we are in ValentinaDB. And we have a query here where we're doing select employee number and we're doing a count of the salary. And the reason we're doing a count is because it will really visualize to you what exactly is happening. So if we do a count of the salary and we were to say order it by employee number, what do you think would happen? Logic would say that, well, if we're going to order it by, we're still going to get the same count, right? And there are how many rows in this table? Oh, 284,000. So we should get a count of 284,000, right? That makes sense. And you would be right. If we removed order by and we just ran it with the normal over, we're going to do it against the whole window of data. So 284,000, 40, 47. Great. But what happens when we introduce an order by? Well, let's take a look at that. So if we execute this, let's see what happens. And what happens is a bit special, and I'll explain why in a second. Well, suddenly, it's counting 17. Why is it only counting 17? This is an order by clause. This isn't a partition clause. Why would it change the way that the window function occurs? If I were to do a partition, shouldn't I be able to count what is specifically in that partition? And yeah, you would be right. Let's say we did a partition by employee number. And then we did a count of salary. What would happen here? What would happen if we did a partition by employee number and then we counted the salary? Well, let's take a look. Well, exactly the same thing is happening, right? Because we're counting specifically how many salaries are there for that employee number. But what happens when we go back to our order by? Well, if we do order by employee number, what's going to happen is a bit more special. And I didn't scroll down for that reason, because I wanted to show you this. When we do order by, if we scroll down here to 10,002, suddenly we have 23. So we aren't counting in the way that you would think. We aren't doing it partition based, and order by isn't a partitioner, right? So we're counting 17 salaries in group 1, and then we're counting 23 in group 2. How is that possible? Well, it's clear that 10,001 goes all the way up to 17, so it makes sense that they have 17 salaries. But then 10,002 goes from 18 to 23, so that's 1, 2, 3, 4, 5, 6. So 6 plus 17 is 23. So it's cumulative. Interesting. Why would it do that? Why did order by change the way that the window function is going to count? Well, order by has a special property. And that special property is called framing. Order by changes the frame of the window function. Okay, Mo, you're saying ridiculous things. The frame in the window? Like, is this a joke? No, I promise it isn't. When you use order by in a window function, you're telling your query and the window function used inside that query, take into account everything before me and myself. So we're changing the lens at which the window function looks at the data. When we remove this, it's pretty clear that the window function is taking into account the entirety of the returned rows. But when we add this, it becomes clear that, hey, we're taking into account itself, so everything itself. But then if we look at 10,002, well, it's taking into account itself and everything that came before it. So it kind of works like a cumulative sum in mathematics. So let's go take a look at what framing is, what it actually does, and let's use it in examples. Because with examples, we can learn way more than we could just looking at some theoretical jibber jabber about, hey, this is all of the things you can do. Let's use it in concrete ways. I'll see you in the next one. We just looked at order by, and we saw that when we use it, it causes strange things to happen. And those strange things have to do with something we call framing in window functions. When you're trying to get deterministic results with your window function, and you throw order by into the mix, it may completely change the outcome of what you were originally doing. And that has to do with something we call framing. When using a frame clause in a window function, we can create a subrange or frame. A subrange or frame. What does that mean? Well, when we look at our data, when we visualize our data inside our mind, when we use partition by, we are basically creating chunks. We're saying, hey, when I get my window back, when I get my entirety of my data back that I'm going to look at, we're saying, hey, create chunks of the employee number. Let's run something against those chunks, or we'll create chunks against another field. But let's take employee number, for example. When we create a chunk against the employee number, we're basically saying, hey, just group these all together with the partition by. Just group these and then we can do something with it. And then it stands to reason when we use count that we are getting all of these 17s here because it goes all the way up to 17. So we're grouping these together logically and we've created that frame. But when we use order by, we're changing the lens at which we look at the frame. Now that's an interesting concept because when we talk about framing, what we're talking about is the way that the window function interprets what it should do against the data. Now, framing comes with a very specific syntax, a syntax that we haven't looked at yet. And when we look at it, we can say rows or range, whether or not you want to use a range or rows as a frame. We can use something called preceding, take all of the rows before the current one. We can use something like following, use all of the rows after the current one. And then we can do something like unbounded preceding or following. Return all before or all after. And then we can say something like current row, your current row. And when we throw that all together, what we can do is we can say something like, hey, create a partition by the category. So group all of my categories together. Then order it by price. And take that range of data that I just gave you from this. And look at everything that came before and the current row. So look at everything that came before and the current row. This becomes very complex and you have to play around with window functions to really understand the nuances with which you can combine partitions and orders and ranges and framing to get the results that you want. But what we're basically saying here is that when we use order by, we are changing the frame. We're changing the frame of reference. And when we look at a frame clause, well, if you don't use order by default, the frame we look at is usually the entire partition. And if you just used over without anything in it, the entire partition is the entire window, correct? We saw that. When you used over, we were running the calculation against all of the data. When we use it without order by, if we use the partition by, it's against all of the partition rows. But when we introduce order by, when we add it into the function, what we're saying is that by default, when you add order by into the mix, the framing is usually everything before the row. So everything before that current row, all of the rows that came before that current row, and the current row. So let's put that to practice. If we're saying that it is everything before the current row and the current row, if we order by employee number, what we're going to see happen here is we're going to see something along the lines in math, what we call a cumulative sum, where we're taking everything that came before. So in this case, this is our very first record, employee 10,001. And if we go down and we look, he's going all the way to 17. So 17 is the number. So we've counted 17. But then if we go to 10,002, we can see that it is 23. So if we see to where 10,002 goes, it goes all the way to 23. So 6 records. 17 to 23, that's 6 records. And you can see that it counted 23. So it is cumulatively counting everything that came before with everything that comes after. And this is extremely special. And this is because we ordered by employee number. Because we ordered by employee number, it is counting everything that it comes across when it counts that specific employee number, the amount of times it occurs, basically, and then it's adding that to the previous sum. All right, so that makes sense. We know now that it's taking everything before it into account and itself. What if we apply it to a partition by? what would happen then? Well, it depends on the partition you're going to do. If we said partition by employee number, what would happen if we do that? Well, because we said that order by with a partition is going to look solely inside of that partition, well, we can know now that it is going to act as if it was a normal partition by. So it's only going to count the 6. It's not going to add it to the previous because it's not taking into account anything that was in that previous partition. But let's say that we ordered by salary. What would happen then? What would happen if we ordered by salary? Well, let's see what happens if we partition by the employee number, but then order by the salary. Will that affect anything? And here we go. Because we're ordering by the salary now, but we're partitioning by the employee number, our partition is the employee number. But our order is the salary. And because they are unique values, now suddenly it's going to look at itself and what came before it, and it's going to add. And because all of these values are unique, because you didn't move forward with the same salary, you're going to go to 1, 2, 3, 4, 5, 6, 7. Now, that being said, if these values did align, if you did move in position but didn't get a salary bump, we may see the same number occur. Now, it stands to reason that usually when your salary changes in the salary table, it's either going up or down. So the number is going to keep counting forward. But the unique thing that we're talking about here is that the way that you partition and the way that you order really influence each other. When we partitioned by employee number, we were taking into account this entire group. But when we look at the order, it changes the way that we're going to look at that partition. It changes the way that our function is going to interact with that data. Our count is now cumulative, right? It's taking into account the previous and the current. So it's very important to know how framing will change when you introduce an order by. It completely changes the way that the function may interact. Deterministic results you may have gotten when you ran a partition can completely change when you introduce an order by. And that's because the way you look at the frame changes. And it's extremely interesting that this type of syntax is used to change the way that the interaction of the window function works, because it is a bit non-intuitive, right? It's harder to read. It's harder to comprehend what exactly is happening. But when you understand the rules around the framing, it can become extremely intuitive as you use it more and more. Now, none of us are going to become window function masters overnight. You have to use it on a daily basis and grind through it and really start to understand the nuances of the different functions and the different framing and all of that. But we're going to give you a hell of a solid basis. Now, with all of that said, we kind of looked at the way that the partition and the way the order works. And we can see now that the order works in a way that it is only taking into account the current frame and the previous, the current and the previous. Now, what if we wanted to change that? Well, we can do that. And we can say range between, and then we can say, okay, take the range that I have, these employee numbers, but range it between unbounded preceding and unbounded following. So instead of you taking into account, hey, all of the previous ones and the current one, take everything into account before and after. And so what's going to happen here, as we see while we execute this, is we're again changing the way that the count is going to work. We're changing the way of the outcome. And now it looks more like what we originally saw, which was the same that the partition did, taking into account the entire partition. Taking into account that whole partition is extremely important. Now, what if we used rows instead? Because that was also a keyword we saw, right? What would that do? Well, that's a good question. Let's see what that would do. And so playing around with this, we can kind of see that, hey, when we use partition and order, the way that we can define our range is within that partition. And the order by influences the way that we look at that frame. But then we can also change the way that we look at that frame. And if we look here, we can see that rows or range didn't really affect anything in this specific partition because we are partitioning. So there are a lot of nuances. There are a lot of things you can play around with here to kind of see how it plays around with your data. And I find count to be an extremely helpful thing to see, hey, what exactly is going on in this range? What exactly is going on in this partition? What exactly is order by doing to my frame? And with all of that, what we get is the ability to run countless types of functions, averages, sums. We can pluck the last value, the first value. We can do a lot of different things. We can get the positioning. Framing is important in window functions, and it can become extremely important when you're doing data analysis. Because, again, order by can take whatever deterministic result you had in your partition and completely change it, because it changes the way that the function is going to look at the data. It's going to take into account the current and the previous. So the current and the previous. Whereas with the partition, you're taking into account the entire partition. So framing is important. And you can change the framing of the partition by using something like range between unbounded preceding and current row. You can do that. You can change the way without having to use order by, and you can still make it operate as if you were using an order by. And that is an extremely interesting concept, because if we did range between unbounded preceding and current row, what we're going to see here is it did absolutely nothing. Now, if we took rows and we did that instead, because we were using range, we used the entire range. Now, if we use rows, we can see that it's operating as if it was using an order by. So, as you could see, the way that you interact with the framing is important. Am I going to take into account rows, or am I going to take into account the range? Am I going to use an order by, and do I have to change the way that we look at the frame? Playing around with this can be extremely useful to wrap your head around, hey, what exactly is going on here? Because this is an extremely intricate concept, an extremely difficult concept to grasp on the first go. And through exercises, I believe that everyone can master the basics and become advanced at this concept over time. So let's look at some examples to make us advanced. So in one of our previous videos, we looked at how do we get the current salary of an employee? How do we do it? How do we get the most recent salary? And we tried to do it with group by, but we really didn't hit the mark. Now, with group by, what we said is, hey, if we join all of these tables and then we do from salaries as S, we can grab the maximum salary. And yes, this is indicative of if your salary is only progressing forward, your max salary should be your most recent salary. But then I posed the question, hey, what if people move between departments and they have to take salary cuts, or there's an economic recession and everyone is taking a salary cut because of that, and that gets logged in the system? Well, then your max salary isn't necessarily your current salary. That wasn't really straightforward. The maximum salary isn't necessarily what you make right now. And so then we said, okay, what if I get the max from date? If I get the max from date, I'll know when they got their most recent salary, right? Well, yes, we know when your last salary was appointed, but we don't know what it was. And so the entire purpose of this video is, how can we solve for this with window functions? How would we do that? How could we get the result through a window function? And so let's take a look at that. Over here, you can see the correct answer. And what you can see is we're doing a select distinct. And if we remember, distinct is going to get only the rows, only singular rows of that value. So we're selecting the distinct employee number. So we only want one value of employee number. Okay, so that makes sense. Then we get their first name and we get the department name that they're in. And then we're saying, okay, well, let's use last value. So if we use last value and we assume that we're going to grab the salary, then we're going to use a window function and we're going to do it over. We're going to say, hey, partition by the employee number. So, okay, logically, we're now partitioning by the employee numbers. So we have groups of employee numbers. And then we say, all right, order it by the from date. So order that partition that we just had by the from date. But now we're in a weird spot because, as we said, with last value and order by, we're only looking at anything that came before and the current row. So how are we going to make sure that we get the actual last value? Well, that's where framing came into play. So if we say, hey, against this range, go between everything that came before and everything that comes after. And let's not follow what order by usually does. Then we can say, hey, get me my current salary because it's ordered by the from date. So I'm sure that when I order it that way, that the last from date's going to be at the bottom. And that makes a lot of sense. And if we do that and we say, hey, this is the last value, get me the last value, then we're going to be sure that we're getting the last salary. So let's run this query real quick. All right, so here we have a shortened version of that same query where we're doing the partition and the order and we're doing the range change. And so what we're going to see happen here is that for the employee, we are getting the last value. We are getting that value that correlates to their last salary date. And how do we know that for certain? Well, it's fairly easy. If we ran that same last value and we did it against from date instead of the salary, we can also see when that last from date was. And so then we can verify, hey, are we actually getting the last date? Are we actually getting that correct salary? And so let's check, because that's a good question. So for 10,001, we already knew that it was in 2002, 0622. So we can now accurately say that, like, hey, this value actually maps correctly to this value. And all of these values are their most recent salary. So we've solved it in a way with window functions to give us a correct outcome. Is this the only way to solve it? No, there are many, many ways to solve this same question. And we'll be looking at different ways to solve this question. Is this the most performant way? Probably not, because you're using window functions and you're applying these functions against the window again and again for every single row. So it may not be the most performant solution. I would argue that it isn't even the most readable solution because I don't like working with window functions personally because I find them harder to read, harder to understand when you're going through the motion of trying to kind of make out what's happening. But it is a way to solve this question. So we've now successfully found a way to answer the question, what is my current salary, once and for all? And with that, we learned a lot about window functions. We learned a lot about how they operate and how these framing and order by and partition work together to get us an ability to answer real world questions. Now, if we were to look at this and visualize this in a way that made a little bit more sense, if we were to look at the salary table, well, then we're selecting the employee number here. So we're getting the employee numbers. And if we did last value against the salary, well, if you were to think about a window function, think about it this way. So we're selecting from salaries and we know we're getting this data back from salaries. So what we're basically doing inside the window function is we're saying, hey, get me that thing that I got from over here in salaries, and let's just do some stuff against that. So when we do last value salary, what we're basically saying is, hey, okay. So now that I have that entire window of data, well, let's go and let's partition that by the employee number. So if I have a match against the employee number, create a partition for me. Just group all of that data together. Put that in a group. And then what we said is, hey, order it by the from date. So for each from date, we're ordering that group. So with each from date, there is an employee number linked, but we're ordering it by the order of the from dates. And so what we're saying here is when we order it, each of those from dates also has a salary column. So we have the salary column. So let's grab the last value of the group of that salary column. So all the way at the bottom, we're grabbing that value, and that is the one we're returning here. And that is a high-level visualization of what is actually occurring when we execute this query. Now, if the framing had changed, if we didn't do between everything before and after, if we didn't change that range, we might have messed this up. And so let's look at what would happen there. So here I went ahead and I removed the frame clause from both last values. And what that basically does is, remember when we had this distinct here? Well, that's not really going to play well with this because none of these values are unique. Therefore, none of them are distinct. Well, each and every single one of them is in their own right distinct because they're unique in their own way. But because they're not the same, we're not filtering them out, is what I'm trying to say. So because we have a different last value for the date of the acquirement of the salary and the salary, well, we now know that we are not getting duplicate rows. So distinct isn't going to filter them out. But even more so than that, because we changed the way that the range looks, we know that order by looks at everything that came before and the current row. And because the current row is always going to be the last row, we now know we actually didn't do anything here. We basically rendered the same exact thing as we would if we just put from date and salary. We're seeing the exact same values. Because if I remove these and I do s.fromDate and s.salary, well, what we're going to see happen here is we're going to see the exact same data come out. And the reason for that is because the last value is taking into account the current row and only up until the current row. We basically use the window function to render the exact same thing out. And that is exactly why our framing here is of the utmost importance so that we take into account the entire range. And that's why we were able to solve this with window functions. All right. So with all of that said, there are so many functions that you can use with window functions. And we've looked at a couple. But just so you know, you can use most of the aggregate functions, some, min, max, average, but there are special ones. There's first value, returns the value evaluated against the first row in the partition. So the very first row. And then we saw last value, evaluates the returned value of the very last row in the partition. And then there's something called nth value. And with nth value, you can say, I want this row number in this partition. And if it's null, it's null. There's something called percent rank to return a relative ranking. There is rank to return the rank of the current row in the partition with gaps. There's something called row number. There's lag and lead. There's a lot of different window functions you can use. And we're going to look at a small subset of them that you would use most often. But just know that the majority of these are to be utilized when you're doing some kind of data analysis, predictive things, when you want to run some kind of calculations or whatnot against the window of data for each individual row. And so let's hop into looking into some of these functions. So let's take a look at the first window function that we're going to focus on. First value. First value returns a value evaluated against the first row within its partition. So if we have a partition, if we have a grouping, if we have some kind of group of data in a window function, or even the entire window, we're just going to grab the very, very first value. Now let's say I want to know how my price compares to the item with the lowest price in the same category. How would I go about doing that? Well, for that, we need to be in our store database. And what we're going to do is we're going to select product ID, price, category, first value of price, and then we're going to partition by category. So we're going to group by the category. And then we're going to order by the price. And then we're going to add in our range clause because as we know, when we order by, we're looking only at the values that came before in the partition and the current row. But since we want the lowest price, we have to order the entire partition from top to bottom in price so that we're sure that we always get the first. Now, do we absolutely need this for the first value? No, not really, because we're always looking at that first value, but it's imperative that we actually make sure that we run it correctly. So let's go look at how that runs. So here's our query, and we're doing our first value over the partition as cheapest in category. So let's see what happens when we don't do any type of ranging against this. Well, we get $9.99 across the board. And will anything change if we add our range change? No, because we're using first value. And because order by works in a way where it's ordering the price in order of everything that came before it in the current row, we'll always know that, hey, with our first value, we know for certain that we're getting the lowest price. If we used something like last value, we're going to see wild discrepancies. Wild. Because we're only taking into account the current grouping by category. So in category 1, we're always grabbing the last value based on when the price changes. So we always want to grab first value. With first value in this particular scenario, the ranging doesn't really matter. Would I suggest you always play around with the ranging so that you can be certain that when you switch it up, that you're going to do the right thing? Yeah, but it depends on what you're trying to accomplish. Is it necessary here? No, not really. And we're 100% certain that we're comparing the price against the lowest price in that category, which in category 2 is $9.99. And it seems that almost in every category, the cheapest product is $9.99. So you may be asking yourself, well, how does that work? So let's take a look at that. Well, if we grabbed products, and then we said we're grabbing the product ID, the price, and the category. Well, if we grab our window function and we said, hey, I want to know the cheapest in the category. So let me grab the window of data that we just had. And if I grab that window of data that we just had, well, let me go and sort them by category. And inside that category, I'm going to order them by price. And because the window function works in a way where even though I'm using order by, it's going to evaluate everything that came before it, I'm pretty sure that when it's ordering, I'm always with first value going to get the very, very lowest price. And because of that, if I match the category, I'm creating the category and I'm sorting the category, that means that I'm going to get the very first value of the price in that category. Now, is this the only way to do it? No, there is an easier way to do it. And the way to do that would be to forego first value in the first place and just use min. And if we just used min and we partitioned by category and we didn't even have to order by price, we would be 100% certain that we're getting the lowest price in that category. And with that, it makes it extremely easy for us. So first value, last value, they're not always necessary, especially when you're working with numbers. It's better to use something like min, max, average, but I want to show you the different ways of solving for the same questions. There is no 100% correct way. Well, there are better ways and there are worse ways, but as long as you get the answer you want, it's all about improving as you learn. And so there are different ways. Is min a better way? 100%. Do we get the same answer? Yeah. It's about building that mental model. And as you build that mental model, as you build that foundation for you to understand how these things are operating internally and how it functions, you'll become more fluent and better as you go. So whatever way you decide to solve something, as long as you're getting the right answer, we'll build up towards that mastery level understanding and comparison of performance to, hey, this is right, this is better, this is best. There is no wrong answer. Unless you're legitimately getting the wrong answer, then there's only improvements to be made from there. So let's go ahead and take a look at our next function.